You're writing. On your paper, guys. Allison, you ready? Okay. James, you got paper back there? Can someone give you paper? All right, guys. So we're doing infinite limits today. There's kind of two types. One where you deal with asymptotes, and then the other where you actually approach infinity, like the end behavior of your graph. 9 examples. Not super long, though. The first 3 they take a little more time, and then it gets quicker. All right, so I'm going to give you the function 1 over x minus 3. What do you have against 1 over x minus 3?
Yeah, I don't like 1 over x.
Don't like any fractions at all, pretty much.
Yeah.
So we're going to start by evaluating the limit of f of x as x approaches 3 from the left. Yeah, because if you look at that algebraically, is there some sort of nice conjugate way we could deal with this?
No.
No. Is there like factoring and we could cancel things out? No. So what we have to do is visualize the graph. Okay. So where is the vertical asymptote on this graph? 3. What would make the denominator 0? 3. That's where the asymptote is. So somewhere over here, I have an asymptote. Okay, now do you remember rational functions? What kind of horizontal asymptote this has? It is 0. Guys, why is it at 0? Let's do. Multiply it.
Like y equals 1 over x. Y is 0.
Right, you can't. It can't equal 0. Okay, yes. Guys, do you remember bottom heavy, top heavy, and equal from graphing rationals? Your thinking is fine. Yeah. So this is technically bottom heavy. Hey guys, up here. So I have a horizontal asymptote of 0. All right, I am not looking for a bunch of points plotted on this. I just need to know sort of the general like placement of the graph. Is it top right, top left, bottom right? Like where do you think the 2 pieces of this graph go? Yes, top right, bottom left, okay? That is the general parent graph shape. If you are unsure at all, if you're like, I have no idea why it would be there, plug in a point on either side of the asymptote. So if I came over here and plugged in a 4, what would I get if I plugged 4 into this? 1. Positive 1, right? Somewhere up here in this section. So I know the graph is in that section. And then if I plug in a 2 on the left side of the asymptote, what do I get? Negative. That's why it's down there. Okay. So when in doubt, you can plug in values. But this is the general parent function where it starts at, those 2 sections, if you will. Okay, so now that we've got this drawn, we're basically back to 11.1. We're going to evaluate the limit by looking at the graph. So as I approach 3 from the left, right, here's the guy coming down here. Where is he going? Not ending well, is it? He's going to negative infinity. Now, is negative infinity a defined value? No. So also DNE, yes. So I need both of those things. You can tell me the direction that it's headed, but then I also need does not exist. Okay, let's try then limit of f of x as x approaches 3 from the right. Is infinity like an actual number? Okay, that's all. From the left? Yep. From the left? So that one's from the right? Limit of f of x as x approaches 3 from the right? You're looking at me like I'm speaking a foreign language right now, so. Okay, so 3 from the right. Here's your guy. Where's he going? Okay, positive infinity. And what else would you tell me? There we go. And let me ask you one more. What about the limit of f of x just as x approaches 3? Yeah, are they going to the same place? Oh, so it's just DNE. Okay.
That's it for the vote.
Well, that's number 1 of 9.
1 of 9?
You guys were chatting earlier when I said there were 9 examples. Pay attention.
Yeah.
All right, let's try again. We're doing, I think, just 3 where, yeah, we only do 3 where you have to sketch the graph, okay? All right, guys, step 1, try to sketch this graph. What does it look like?
A little weird for that.
A little weird parabola.
Is that wrong? Oh.
That is wrong. And here, 0 is an asymptote. I like that.
What? Negative 1. It's still positive. Only positive. Yeah. No. So is it only?
Chris, how's your graph going?
I don't know what to do other than zero asymptote.
Okay, if you're stuck, plug in a 1, what do you get?
1 over 1.
So that means this part, right?
Oh, it's still gonna be like that?
It's still a rational graph, yeah.
Okay, so the asymptote is also 0. Vertical.
You have a vertical and horizontal as 0.
I like that.
Yes. Where's the other part, guys? I hear top left and I hear down. Let's think about it.
Top left. Negative 1. That's top left.
Yeah, because when you square it, it's positive. Does that make sense? That's weird. Sure. I can give you weird graphs. It's okay. All right. So the 3 things I'm going to ask you are very similar to before. Limit of f of x as x approaches 0 from the left. Limit of f of x as x approaches 0 from the right. Limit of f of x as x approaches 0. Try to answer those 3. What'd you say?
Positive infinity being same thing on the other one, and then being normal. Oh, they go to the same. Is it causing infinity?
Yes. Are we getting the same answer for all three parts? Yes. Okay. Okay. Anybody questions on that one?
It's not that scary.
It's not that scary, yeah. All right, last one that you have to make a graph of, okay? Because those are the ones you have to make the graph of.
Is that
You
you?
see factoring in your future. You are wise. Two.
Oh, thank God. I don't know. Should we factor first?
Yep. Squared. Include that in your graph. Because I'm probably going to ask you something about that. All right, guys, those are the three things I'm going to ask you. Yes, thank you. That makes way more sense. I mean, you could do the other, but that's not really connected to the graph.
Yeah. Is there an asymptote at x minus 5? So then that's
It's greater than 0? What do you mean?
Wait, so it's there's an asymptote at -2.
Correct.
And then is that a hole then?
Yeah.
I'm still there's a hole at x.
Oh yeah.
There's just a hole at x at 5.
When x is 5, how would you find the y part of that coordinate? Okay.
Y minus 5 is 0, 0. 5 plus 2 is 7. So it's 5 and 7.
1, 7, right?
Yeah, Oh yeah, 5. Wait, no. What?
1 over x plus 2.
Isn't that what you have left?
Oh, I completely forgot to close that. Yeah.
There's a hole somewhere over there. Do we have a horizontal asymptote?
Yeah, 0.
0, okay. All right, let me go through the factoring just to make sure we're okay, but it sounds like you guys are. The x minus 5's cancel. That's how we get the whole at 5, 1/7. Are we okay with that? Okay. So for shape of this graph, are we fine with it being here?
And at the bottom.
And that one, is that what you're saying?
Wait. Oh, okay. Do this.
Yeah, we're good with the graph? Okay.
And then so when it comes to finding the other side, would you plug in a number on the other side of the asymptote?
Yes. Yep. And most of the time, it's going to be like this where they're across from each other. It's only if we had that, like we had the weird squared one and they both ended up on top. But this is sort of the general basic of what it should look like. Okay, guys, so -2 from the right. What are you going to tell me?
Positive, positive.
Excellent. All right, what about just as x approaches -2? Yeah, good. All right, and then don't get tricked by part C here. As x approaches 5, 1/7, yeah. Remember, it's just what y value are you approaching? It's fine that there's a hole there. You are walking right up to the edge of the hole. That is okay. The left and right sides would match. You're both at the same y value there. Yeah? So are you okay with we have this 1/x + 2 left? After you factor and reduce. Okay. Plug a 5 into that. And that's where it comes from. Yep. Other questions on these three? Krish, put your phone away. Thanks. That's not really away, but down is better than nothing. All right. Yeah. Like for letter B. Okay. So you see how the left side and the right side are going different directions? So it's going to have DNE because there's an asymptote. But it's not like infinity and DNE because they don't go the same direction. If they both went this way, then it's infinity DNE. This, just DNE. Okay. Anything else before we move on? Okay. All right, let's try again. Okay. We don't have to make a big graph here. What I'm going to ask you now is the limit of f of x as x approaches infinity. Negative infinity. So I'll let you jot that down and then I'll explain what you should be looking for. James, phone. You don't need to draw a sketch for this one. You can. It's never a bad plan to draw the sketch, but you don't need to. Okay, we are talking about x approaching infinity and negative infinity. That's called the end behavior, right? Okay, the ends of your graph. So what we need to think about is there a horizontal asymptote? Okay. And again, this is end behavior is what we're trying to figure out. Okay, I'm hearing a lot of 1/2. That is correct. Why do we think that?
At the bottom. Or you're like, I don't know, negative. I mean, correct, but it's still like, wow. You just make it 0, you +1, over 2, something.
We're getting creative. Okay, this is back to the horizontal asymptote of your rational functions. Top heavy, bottom heavy, or equal. What is this one? Equal. Equal. When it's equal, you can look at those leading coefficients, and that tells you where the horizontal asymptote is. Because if I took x divided by 2x, what would I be left with? 1/2. That's where the 1/2 comes from. Okay? What's essentially happening is if you're plugging infinity in, that means you're plugging in like a really big number, right? So you have a really big number over 2 times a really big number. That gives you 1/2 when you simplify that. They're growing at the same rate, like your numerator and denominator, okay? So you can just look at the coefficient. So whether we're going to positive infinity or negative infinity, your graph is still going to approach the same y value. Again, you don't need to sketch it, but it is a rational function following that horizontal asymptote to the ends. Okay? With most of these where it's x is approaching infinity or negative infinity, there's very little like work to write down and show me, but you do have to think through what is happening with the graph. Let's try again. So you guys, we're already on number 5. I'm gonna make it. All right, same 2 questions. Talk to each other. Can you answer this? Do you think? Yeah, you've got no one around you. You should go sit with Thomas over here. You guys are all alone. Bottom heavy means something.
That's right. I remember. It's 0. Yes. So that means it's 0, 0. Right? Oh my God. How do you want it? I don't know, I guess.
I'll explain why. It is 0 for both of these.
This was, what unit was this? Unit 2? It was really early.
It was early in the year, yeah.
I mean, no,
You learned it in Algebra 2, and you learned it again this
I
year.
don't remember getting it.
We graphed rationals. Yeah. We don't, it's not something we spend a lot of time on, because it's one of those where I'm like, remember from Algebra 2, and then we keep going. It's one of those. Okay, but let me explain why this works. Some of you are just, like, you have it memorized that, okay, it's bottom heavy, it's 0. And that is absolutely fine to memorize that. What's happening in your fraction, though, is as x approaches infinity, you're essentially plugging a really large number in for the x. So you've got 3 times a big number on the top, but then you have a big number squared in the denominator. Which one of those is growing faster? Squared, right? Times 3 doesn't grow as fast as squaring. Okay? So the denominator of your fraction is getting bigger faster than the numerator. So if your denominator is big, what is your fraction actually doing? Getting small. Yeah, because like 1/1,000,000. Isn't that really close to 0? That's what's happening here. That's why that works. It's fine if you're like, oh, bottom heavy 0. Like, that's good. But I want you to understand why that is happening. When you get into calculus, you'll start talking about, like, the rate at which things grow. And so that's going to matter. Then it has a slant asymptote, and we're going to...
I remember doing those.
Okay.
We did it this year.
We did it this year, yes. We will definitely do 1 or 2 of those today, okay? We won't actually do the division. We'll just talk about where it's ending up. You're getting very close.
Long division. Oh my God. Math is crazy.
You're excited to review for that final cumulative, aren't you?
No, I'm a little scared to be honest.
All right. Same 2 questions.
I was on the
Yeah. Part 3. You do. Yeah, so next Friday we review for that, and then the next week, I think it's Wednesday, Yeah. And then review again, and then take it. Yeah. Yep.
What's top heavy, so it's a slant asymptote.
Yeah, but where? So let's talk about that.
Isn't it like a y-intercept? Or not a y-intercept, so like a line. And
Is it a line this
it is a
time?
line, but there's some way to find it. And I don't.
There is a way. I'll let you jot it down, and then I'll explain it. You're thinking good things.
Like y equals x plus 2.
No, but good try.
That's not the line.
We're not going to find the exact location of the slant asymptote because I don't really care. I'm not graphing it. I just need to know, like, where is it headed, right? General direction here. So if I look at this, x cubed minus 1 over x plus 2, we all agree it's top heavy? Okay. So what you did when you were graphing it, you actually did long division to find the location.
I don't want it.
We're not doing that right now. There's no need. What I need to look at is this x cubed over x. The reason I only care about the highest degree, think about plugging infinity in. If I cube infinity and then subtract 1, does that minus 1 really matter? No. Pretty insignificant compared to everything else. Same with the plus 2. It doesn't impact what the ends of the graph are doing. So x cubed divided by x. What is that?
X squared.
That's x squared. What does x squared look like? Okay. So where are the ends going?
Up, up, up.
There you go.
Oh, gee, it's negative, it's positive.
Up, up, and away to infinity and beyond. What'd you say, Shimon?
What happened to the negative one?
So they're kind of insignificant.
Ooh, no,
If you're plugging infinity in, infinity cubed, and then minus 1, doesn't matter.
I'm gonna go for more though. Adam's gone for you.
Hopefully, Adam's not lost. All right, guys. This one we're gonna have to think about a little bit. Oh, thinking required today. Not a lot of like writing down work required, but thinking required. You ready for thinking? Okay, again, do I care about the minus 1 and the plus 2? I do not. I care about this 2x and the square root of 4x squared, right? That's what I'm really thinking about.
Wait, didn't that cross out?
It's 2x over 2x.
Close. Yeah, it is balanced, but we have to be careful because of the square root. So let's think about our whole, like, putting infinity in. If I put infinity into the top, I get 2 infinity, right? And beyond. Okay. In the denominator, when I put infinity in, I get 4 infinity squared, and then the square root of that is 2 infinity, right? So what do this is not like good notation there at all, but thinking through, what is it going to be? 1. Okay, that is the limit. That is absolutely what it approaches as you go towards positive infinity. So that one's not bad. Like, that should make sense. But let's think negative infinity. Okay, square roots, negatives, probably need to think a little more. So same thing I'm plugging into, the 2x over square root of 4x squared. So this time I've got 2 and a negative infinity. When I plug that negative infinity in down here, or negative infinity, it's still 2 infinity, right? So what does that become? Yes. Okay? Not hard, but you just got to take the time to think through what's actually happening there. Okay? Questions so far? We only have 2 more to go, and they are the easiest 2 of the day.
Wait, so like in the beginning, you know how we were graphing? Is that like required, like for certain?
So do you see how the questions here are different? They're all saying as x approaches infinity. But look at the ones we did first. What did x approach?
It approaches a certain number of like.
Yeah, where the asymptote was.
Oh, okay.
So yes, I would sketch them. Okay. Yep. All right, guys. Limit as x approaches infinity. X cubed plus 2x squared minus 7. So no parts A and B or anything like that. Just that limit. Can you do it?
I don't want to.
I'm telling you, this is like the easiest one we've done today. Okay.
No.
I wouldn't really plug in infinity. What do we do? Can you visualize a cubed graph, a cubic graph?
I mean, I can do that and a parabola.
Does it do something like that? It's a terrible drawing, but okay. So as x approaches infinity, okay.
Okay.
Okay, so again, we're sort of only paying attention to the highest degree. Because when we're talking plugging in infinity, these are going to be insignificant. Okay, this is what I care about.
Why is it insignificant?
Cubing infinity is going to be much more important than a minus 7, even a squaring infinity. Like, okay, so that's the part that determines what's happening. This is the shape. That's all you have to do is visualize a cubic and what happens. Okay, one more. Kind of like that.
Over the deck.
How do you do that? How do you do that?
Yeah.
Oh, it's a dub root. So when you plug it in there, you get the state and positive.
Why are you plugging? What?
Is that the answer?
Hold on.
Yeah, I'm not even writing.
So guys, that is a 4th degree polynomial with a negative leading coefficient. What are you visualizing? This, yeah. This, right? So as x goes towards infinity, your graph goes towards negative infinity. Yep. You got it? Okay. All right, guys. We are quizzing next. Let me save the video.